Thinning southern pine forests is a practice that is gaining more attention in the United States as landowners recognize the many benefits that result: intermediate revenue from wood products, and a greater value realized from sawlog production at the end of rotation or from subsequent thinnings are only some of these benefits. A growing emphasis on pine plantation management has led to the need for greater knowledge by foresters and landowners concerning thinning systems. Thinning can result in both positive and negative effects on the forest. If not properly planned and implemented, however, the outcome of the thinning may not meet the landowner's expectations. The growth of a tree within a stand is most greatly influenced by the local environment surrounding that tree. Each tree must have adequate water, soil nutrients, and sunlight to achieve vigorous, healthy growth. If any of these factors are lacking because of excessive competition between individual trees, the growth of a tree is reduced, and the time required for the tree to reach physical maturity increases. Growth of individual trees in a forest stand of southern pines is a result of several factors, including site quality, stand age, stocking level, forest management practices, and harvesting systems that are employed. Let's look at each of these factors a little more closely. Site quality is a given for your stand and is not within your control, but you can control the other factors that influence forest stand growth. Site quality can be thought of as an indicator of the potential for tree growth. The measure of site quality commonly used by foresters is site index. Site index is a prediction of the height of the dominant or tallest trees in the stand at a future age, usually 25 or 50 years. In the southeastern U.S., site indices for southern pine usually range from 55 to 95 at an age of 25 years. The higher the site index, the more productive the site will be for timber production. The second factor influencing stand growth and development is stand age. In even-aged pine stands, where all trees are of the same age, management is simplified because the stages of development are similar throughout the stand at any given age. All trees in a stand will reach sapling size at a similar age. Uniformity occurs to a lesser extent as the stand matures to sawlog status. Picture for a moment a forest stand. The individual trees can be grouped into four crown classes. The dominants are the largest, tallest trees in the stand. The co-dominants are those trees with crowns in the upper canopy, but below the dominants. Intermediates are smaller, shorter trees with crowns below the main canopy. Trees that are suppressed are the shortest trees in the stand. They have been overtopped and will eventually die. As stand age increases and the stand matures, natural competition for water, soil nutrients, and sunlight increases the potential for growth in the dominant and co-dominant trees. The intermediate trees grow more slowly, and the suppressed trees gradually die out to naturally thin the stand. Another factor which affects the growth of southern pines is the stocking level of the stand. The stocking level of the pine stand is a representation of the amount of wood fiber present in the stand. Stocking levels can be expressed in several ways. The more common representations are trees per acre and basal area. The number of trees per acre that a site can support is dependent upon the size of these trees. As the stand matures, the number of merchantable trees per acre will naturally decrease due to competition. Basal area is the sum of the tree cross-sectional area in square feet per acre. The amount of basal area is reflective of the quality of the site or site index. Higher site indices will support a higher basal area. Now that we've clarified some basic principles, let's talk about some forestry practices and harvesting systems that are commonly used for thinning southern pines. If producing pulpwood is your primary management objective, the value of thinning is questionable. Research in forest management has shown that for a normal pulpwood rotation length of 25 to 30 years, most thinnings have very little influence on cubic volume yields. But if the stand is young, say less than 12 years old, and extremely dense, you may want to consider pre-commercial thinning to prevent stagnation, especially in those places where individual tree growth is nearly halted. If you are managing your forest for saw logs or other solid wood products, thinning is especially important. Once you have decided thinning should be a part of your management plan, when should you begin? From an economic perspective, you will want to delay the first thinning at least until the revenue from the harvested timber offsets the cost of the harvesting operation. From a biological standpoint, you will want to thin just prior to overcrowding and reduction of stem diameter growth. How can you easily tell when this reduction will begin to occur? A good rule of thumb for first thinnings is when the live crown ratio, or ratio of crown length to total height, is approximately 1/2 to 1/3 of the total tree height. Generally, this occurs between 15 to 18 years on typical sites, but if the initial plant spacing was close and you have a better than average site, the time for first thinning may be as early as age 13. Once you have determined that it is time to thin, you will need to decide how many trees to remove. The intensity of the thinning is a trade-off. Heavy thinning will promote rapid diameter growth, but will result in poorer use of the site's resources and lower product quality. An example of such a thinning would be to leave only the final sawlog crop trees after the first thinning. To achieve maximum pulpwood and sawlog production, we recommend more frequent, lighter thinnings. Basically, you are salvaging the trees that would die from suppression and decay in the woods. But be sure to remove enough trees to make your operation economical, usually 5 or more cords per acre. Ideally, you would remove 30 to 45% of the stand basal area, while leaving 60 to 90 square feet per acre of basal area. Remember, the higher the site index, the more residual basal area you can leave, and residual basal areas will be lower for first thinnings than for later thinnings. Now that you've seen the best time to thin and how much to remove, you will need to determine the method of thinning. Two factors you should consider are quality of the residual trees and costs involved in timber marking and harvesting. You must also be prepared to make a trade-off here. The method of thinning that will give you the greatest growth response is also the most expensive. The methods of thinning a southern pine stand fall into two general categories: selective methods and mechanical or systematic methods. Selective methods involve the removing of trees based on their position in the crown canopy. Selective methods usually require timber marking, which indicates to the logger which trees you would like to remove. Selective methods generally are grouped into three major types. Low thinning involves the removal of suppressed and intermediate trees. Your main purpose here is to remove mainly pulpwood trees and to leave larger, high-quality trees for your sawlog crop trees. With crown thinning, the emphasis is on removing dominant and codominant trees of sawlog and chip and saw size. When using this method, you will remove higher value trees and leave the smaller pulpwood sized trees to grow into sawlogs in the future. This concept sounds appealing, but is difficult to apply to southern pine. The more suppressed the individual tree, usually the less likely it will respond to thinning with vigorous growth. The result is a very poor residual stand. A third selective method is selection thinning. With selection thinning, you determine which trees to remove based on tree size, quality, and the proximity of a tree to its neighbors. You are thinning the denser clumps of trees to open the crown area for growth. With each of these three selective methods, you will remove trees that have been damaged by disease, insects, and storms. In marking your timber to cut, place a paint spot where the timber feller can see it. You will also want to place a spot on the stump. Marking trees in this way will allow you or your forester to later verify that only marked trees were harvested. If you are making a final thinning and want to leave only 100 trees per acre or less, you may want to mark these crop trees and leave everything else unmarked. This will make it easier for the timber feller to locate which trees to cut. The second general method of thinning southern pine is the mechanical or systematic method. The systematic method is widely used in first thinnings because of its simplicity. With the systematic method, you will remove trees strictly on the basis of spacing, with no consideration for the crown position, size, or quality of any individual tree. Systematic thinning consists of row or corridor thinning. For example, in a plantation, you might remove every third row for best results. The greatest disadvantage to such an approach is that you are removing a fixed portion of the best crop trees from the stand and leaving a large portion of the less than desirable trees in the stand. Some of the biological disadvantages to strict row thinning can be overcome by combining row thinning with the selection of suppressed and diseased trees in intermediate rows. This approach is better than systematic thinning, but not as good as selective thinning alone. To allow enough time for residual trees to respond to thinning, mechanical thin when the stand is fairly young, before age 17. A final factor to consider in thinning southern pines is the harvesting system you plan to use. Generally, harvesting systems used in thinning southern pine plantations are one of three major types. One is fast disappearing, the second is most widely used, and the last is on the horizon. Until the 1970s, the bobtail truck chainsaw system was the most widely used system for thinning pine plantations in the South. This system requires a low capital investment, is highly maneuverable for selective thinning, causes little residual stand damage, and can be used to harvest small tracts of timber. Felling, limbing, and bucking are done at the stump. The bobtail truck system is a labor-intensive system with a low productivity rate, has higher labor cost, and is sensitive to adverse weather and ground conditions. Additionally, access roads are required to be cut throughout the stand. A variation of the bobtail truck system is the forwarder system. With this system, felling and bucking is still accomplished with a chainsaw, but loading and in-woods transport is accomplished with a forwarder equipped with a self-contained hydraulic loader. The forwarding system is more productive than the bobtail truck system, is less sensitive to adverse weather conditions, and produces minimal stand and site damage as less access roads are required. Another system that is used more widely in the South for thinning is the feller-buncher rubber-tired skidder combination. The feller buncher can easily perform the work of 4 or 5 chain operators and is less sensitive to weather conditions, but it has a higher capital investment and is more likely to damage the remaining trees and can cause site damage. Limbing and topping are still required to be performed by a chainsaw or other means. The rubber-tired skidder, either grapple or cable, is also highly productive and easily brings in loads of as much as 3/4 of a cord. However, the skidder operator must exercise care in pulling trees from the woods to the landing. The long load being skidded can easily damage residual trees, and many passes over the same skid trail can result in soil rutting and compaction. Once the harvested stems reach the log deck, they can be bucked to pulpwood lengths or loaded with a knuckle boom loader as tree length material. Operating this system economically requires much larger tract sizes than the bobtail truck system. The system also works best when you use a systematic thinning method and requires more intensive harvest planning in order to minimize residual stand damage and to perform economically. Another system that is showing more potential as an economical method of thinning is the mechanized cut-to-length system. This system has been used successfully in the Scandinavian countries. The mechanized cut-to-length system involves two basic machines: a harvester which fells, delimbs, and bucks the stems selected for thinning, and a forwarder which has a load capacity of 3 to 5 cords. The operator of the harvester has usually been trained to select the trees for removal, thereby eliminating the need for a separate timber marking operation. Once the harvester operator has selected a tree, he can fell, delimb, and buck from the safety of an environmentally controlled cab. This machine also has a computerized length and diameter measuring capability. This capability gives the operator the option to recover small chip and saw logs from the first cut of what might be a pulpwood stem if a tree length system were being used. The harvester places saw logs in one pile and pulpwood in another, which allows the forwarder operator to transport the material to the proper location at the log deck. Once the forwarder wood rack is filled to capacity, the forwarder moves to the log deck to transfer his load to a waiting trailer. The advantages of the mechanized cut-to-length system are that it operates well in selective thinning methods, separates products in the woods, causes minimal damage to the residual stand and site, and requires only two operators in the woods for the system to function. The major disadvantages of the system are the high capital investment required to purchase the system and a higher level of skill and training on the part of the operators, which means that a greater investment must be made in training these workers. In this analysis of thinning the southern pine forest, we've examined the environmental factors that contribute to the growth of your forest stand. We've looked at stand age and how to determine the vigor of individual trees by their position in the crown class. We've also discussed stocking level and how much basal area should be removed during a thinning and how much should remain. And we've examined several timber harvesting systems used for thinning pine stands. If you perform thinnings properly, you will reap a number of benefits, including increased product value, better site usage, and greater income from your forest land. In addition, your forest land can provide more water to improve stream flow. Your wildlife habitat can be improved, and the aesthetics of your forest land for recreation can also be improved. Thinning is an option that you should seriously consider in your forest.